So today we're going to talk about the difference between motors and generators. So how do we use electrical energy and why does it need to be converted? So electrical energy is really difficult to see and study. So instead of trying to study electrical energy directly, we convert it into mechanical energy or the energy of motion before we start to study it. So motors were invented by Ørsted, and the input energy for a motor is electric. And the output energy for a motor is mechanical. So think about toys that you have to put batteries in when you're younger. So an electrical current is going to flow through a wire, which then is going to create a magnet. So again, that electric current creates a magnetic field. And the magnet is going to be attracted to another part of the machine, so therefore it's going to move. For example, a doorbell. So you create that magnet, the machine moves, and then your circuit is complete, and then you hear the sound of your doorbell. The parts of a motor include the armature, which is the spinning part of the motor, the commutator, which provides electrical contact, and the current flows to the coil through the commutator. The shaft is going to support the coil and provide the axis of rotation. And then the brush is the stationary part that connects with the rotating commutator. So as the commutator rotates, it connects with the brush on and off. So here the coil will rotate clockwise as the magnetic field is north to south. Those brushes on the side carry a current to the coil via the commutator, and the commutator reverses the current. This will help change the polarity so it keeps the coil rotating in the same direction, or else it would just rotate halfway around and then stop because it would be attracted to that side of the magnetic. So we have to change the flow of the current to change the polarity of our coil. So an electrical current creates a magnetic field, and then the north end of the wire is attracted to the south end of the magnet. So then we're going to have rotation, a half turn. Again, then those brushes and commutator are going to touch and reestablish current, but the current is now reversed and the coil continues to spin because the north end of the magnet and the north end of the coil are at the top. So they're going to repel and then push back around. Now this reaches the beginning and then repeats. So we're going to have attraction, repulsion to keep that coil spinning. So generators were invented by Faraday, and the input energy for a generator is mechanical. So for a motor, we input electrical energy and get mechanical. But for a generator, we put in mechanical energy and get electric energy. So even if you think about the generators that you use if you're camping or outdoors, we have moving parts inside and we get electricity as a result from it. So when we're looking at a motor and a generator, the problem is the current only flows when the commutator is connected to the brushes. So there's two ways that we can do this. We can wrap more wire around the core, which increases the current, or we can have a split ring design, which increases the contact time. So we want to increase the amount of contact that there is to increase the amount of current. And electricity can be produced in two different formats. We can have direct current and alternating current. So direct current is when the electrons flow in a continuous loop in one direction only, and this is typically coming from a battery, and it cannot be used with transformers. So if you have a car or RV battery, you're getting direct current. If you have a rechargeable battery for your phone, you're getting direct current. If you have Duracell batteries that you put into a toy, you're getting direct current. Alternating current is when electrons flow in one direction in the circuit and then they flow the other way. And this happens from a generator, and we can use it with transformer stations. So when we have energy coming to our house through power lines, this occurs with an alternating current. So here would be a graph of direct current where we have a constant flow of electrons in one direction, and then alternating current where we can see where the electrons will switch their flow to the other direction. So in our house, we use alternating current to power all our appliances because alternating current generators are what's used to power our houses. Now, to maximize the energy output using alternating current, we want to increase the number of turns in a wire, spin the armature as fast as possible. We want to use strong magnets and have an iron core inside the wire. And that will help maximize the output energy of an alternating current system.